just getting set up here if you guys are actually hearing live. We're going to try to do a call-in version today. So I'm working on that now. We're going to actually do that on a Google Meetup. And one more person here. So they're actually here. So Gannon, if you're in the live chat, guess what? Check your email. Oh, we lost somebody. What in the world? I'm disappointed. So sad. I need a bigger setup here, I think. Is that so centered? Come on. All right. I'm trying to figure out how long the delay is. Just for a minute. There's the speakers in the front. Oh man, we still have 6 minutes here. Nobody's in the chat. Alright, let's get the first one set up. See how long the delay is from you writing down. Well, I hope everything's going well with all of you. Yeah, it's about 30 seconds, 20 seconds. Guess. Special guest hasn't shown up yet. Actually, we're going to start off with 2 of them. I feel like maybe I should put this down here so I don't project the lights. Oh well, next time, right? Ooh, we're up to 3 concurrent viewers. Hello, viewers. Obviously, hit that subscribe button. Like the video. smash that little bell so that you can get notifications when we review. Oh, we lost him. That's just... That's 3 minutes. And maybe our guests will join us later. Give me 1 minute. Let me try something real quick. Otherwise, I'm going to be looking at the Google Live shot, and it's not going to be as effective video. Not that I'm going to monetize this. Got to have good habits if I'm going to be Jeopardy game show host. That's for sure. Oh, this almost works. Back. Hey, we got one. What do you, don't put the stapler to your head.
It's not a stapler.
Oh.
It's awesome.
What? Are you talking to somebody else or are you talking to me?
No, I have like thousands of messages that I haven't ever listened to.
That would do it. All right, where are we at? 2 people on the live stream who have yet to say boo. So I'm assuming they're bots from Japan or China or something. Maybe Russia. You know, we must figure out what the good American education is doing during the quarantine. So, special guest Mr. Vokes, we are about 20 seconds ahead of the YouTube channel.
Okay.
So if you could pull, I don't know if you have the YouTube channel pulled up or not.
Yeah, I do. I'll pull it right now.
I've already invited super special guest number 1. But if people ask to kind of jump in and ask questions live, then just send them the link to the Google Meetup. This 20-second delay on my streaming thing just is annoying, but it's so cool. I'm going to just adjust the camera one more time for those of you playing along at home or overseas. Ooh, this might actually look even better. Ha ha ha. Alright. That sounded exciting. Garble, garble. The people at home, I have no idea what the sound quality of our special guest, Mr. Vokes, is going to be because we're technically doing it through my Chrome, but we're doing a Google Meet through my Chromebook so that they can see it live versus the 20-second delay that you guys are on.
Yeah.
The benefit, however, is then if you have questions and want to ask them live, say something in the YouTube chat, Mr. Vokes will send you a link on your email and then you can jump on in. Much like if you've ever been on radio, there's going to be a delay so that you'll be joining us actually live and the 20-second delay is so that way, theoretically, we can dump the feed before the swear gets out. But there will, none of your video will make it on, so don't worry about that. So what else? What else do we have to usually say about when, you know, Mr. Vokes, you've listened to the radio before in talk shows. I'm going to guess none of our students have.
Yeah, I love actually listening to them a lot. I used to listen to them a lot when I was younger, but now I'm more of a podcaster. So.
Oh, a podcaster? So you make your own?
I podcast myself, but.
Oh. All right. Well, we're not going to waste any more time here, I don't think. We're at 1:02, so we're going to go ahead and just jump right in. Our first special guest apparently hasn't checked his email. So, if you happen to know Gannon, shoot him an email, text him. Tell him that we're waiting on him. Anyway, so we're going to go through both groups from yesterday's homework problems. If you like my class, I think probably about 2/3 of you guys finished it, so hopefully this will give some of you guys a push. We'll go through one by one. We're also going to spend a little time in the midst of these. If you've watched our other videos, this probably isn't going to be a surprise, but kind of just talking through etiquette of how to do these. Because some of you guys are very, very sparse, and if I went through and gave you as little as you guys did on some of my videos, some of your problems, you would be yelling at me saying, how in the world did you do that? So instead of making it look like an answer key, let's make it look like something that people can understand. All right, so they're asking us to prove this side of the fraction, cosecant squared plus 2 cosine theta, or cosecant squared theta plus 2 cosecant theta minus 3 over cosecant squared theta minus 1 is equal to cosecant theta plus 3 divided by cosecant theta plus 1. Remember, you need to start with one side and end on the other. You cannot play both sides as you go. Apparently people are texting me. I'm sorry, I should have turned that off. I'm a bad
I do like the Mandalorian text message, though.
Hey, you got it. If you're going to speak in the language of the people, you need to be able to, draw them in.
Yeah, I agree.
So, anyway, Mr. Vokes, what side do you think we should start with?
So I think we should work on the left. I think that's a great option.
You should usually start with the more complicated of the two. It's usually easier to make complicated into simple versus, it's easy to make simple into complicated. The hard part is making simple into the correct type of complicated. Apparently my stream's bitrate is having an issue. Well, too bad. It was working just fine. Oh, that's what you get when you pay for whatever. So, we're going to start on the right-hand side. So we're going to rewrite the left-hand side. So cosecant squared theta plus 2 cosecant squared theta minus 3. I want to know how many people are going to do this later, just because that way we can fast forward through all my jib jabs. So, first thing that hopefully strikes you is this. I have a square cosecant, I have a plane cosecant, and I have a constant. The first thing in the back of your head you should be thinking is, hey, this looks a lot like x squared plus 2x minus 3. And the answer is, you'd be right. What would you do with this? Oh, I'd factor it, Mr. Hayes. Guess what? You should factor that. Anything strike you as odd about the bottom there, Mr. Vokes?
It looks like it's also factorable. I think it's what we call a difference of perfect squares.
You mean I just can't take the square root of both sides right now?
Well, it's not an equation, so I don't think we want to try that.
Okay. I understand that some of you guys, maybe in your enthusiasm, might be all excited. So even if you don't know where you're going, and we do know, remember, we're going to end with this. Sometimes just taking that step and saying, okay, what do I get? Because again, remember, we're trying to say, okay, we want this to end with this. Okay? So as soon as we can get that type of stuff built into what we're doing, the better off we're going to be. So anyway, if you look, hey, I want that and I want that, this stuff's the crap I need to get rid of. Can I say that on the internet?
I don't know.
Okay.
We'll find out.
Well, the definition, I find it interesting, the definition of children by YouTube is 13 or younger, so since we don't have any 8th graders here, we don't have to check that little children's box. Yeah. So anyway, so this cosecant theta minus 1, look, I've got 1 in each of these things, and those both go away. So again, notice what I ended up doing from here to here. I factored. Whoa, that's ugly. That's disappointing.
And the big thing I think about that idea of the factors going away is that they divide through to be 1. I always like to say that out loud too.
Sure.
I think that helps you guys, that helps you guys think about what's going on. I think sometimes it seems like it's magic.
Yeah, and that's one of those things, and I think that's sometimes people say cancel out, and the problem with saying canceling out is it just sounds like they just disappear. Dividing out is a lot more accurate in what's happening. They divide out to be 1. So then you've got that identity clause that nobody ever teaches people in for 1 anymore. And so then that will give you this over here. Hey, guess what? We are done. That seems simple. Yeah, it was kind of supposed to be. But since I don't think we had much from last week that involved the factoring stuff, so if that was one of those things that threw you, double check that. The other thing to think about too is remember, if the trig is throwing you, just do what I did over here. Okay, over on the side is perfectly fine to do some work.
So
yeah, as long as they're the same identity. Thank you, Mr. Vogt.
Yeah, we have a question from the people. It said, so like if we have cosecant, tangent, and other things like that, can they be replaced with variables for factoring? And if we think back to first semester, right, we have use substitution.
Yeah, so like, and again, this isn't one that we did, but let's take the same idea over here. Let's say if I had cosecant squared theta plus 2 cosecant theta, and there's going to be a whole bunch of reasons why this may or may not work. I'm just doing this off the top of my head. So let's say cotangent theta plus is going to be minus 3 cotangent squared theta. That would be perfectly fine. When you go to factor it, you would just have that secondary link over here. So you would have cosecant theta plus 3 cotangent theta, and then cosecant theta minus cotangent theta. Yeah, and that's perfectly valid. In fact, yeah, you may actually play around with stuff like that in the second and third problems that we're about to do. So whoever did that, if I was here, I'd throw butterscotch at you because it's a beautiful segue. And when I say segue, I don't mean
I
like...
have that ability to have candy right now.
Yeah, I know. Oh, well. And when I say segue, I don't mean like, the Segway scooter thing. I mean like...
Correct.
Okay, just check. So, Mr. Brooks, how have you been spending your time as we...
I've just been trying to get some stuff done around the house when I'm not doing schoolwork, So trying to catch up on projects that have, gone lost with all the time that I don't have. And now that I have time to do them, I'm trying to pick up on some of those projects,
Ooh.
And cooking. I'm cooking a lot of things.
Ooh.
Yeah.
Anything good?
Last night it was turkey tostadas. So those were pretty good.
Wow.
Yeah.
Look at you, Master Chef.
Trying.
All right, so number 2. This one, interestingly enough, you can kind of attack it from a couple of different sides. And I'll kind of explain where I'm thinking about that. So, prove. We're number 2. The quantity of cosecant theta. Is my audio on YouTube okay, people? Problem is that sometimes this doesn't get super dry.
It's fine for me on this. I can check. Let me check the YouTube audio too.
Okay. I bought a new microphone. It's like, ooh. So, anyway, might help if I actually put it on. So anyway, so we got the, holy crap. Let's put you on the sideline, Mr. D. Grab the other detector. That's even worse. You get thrown away. I think you're going to wonder why there's a marker in the flower bulbs, but What can you do for it? Wow. I put this marker.
There's so many malfunctions with the markers. That's never happened before.
I know. I've got some new ones that are like inch, that are going to be an inch thick. It's going to be like amazing. I'm hoping.
Yeah, that color looks good.
For the price I paid, it better be. So Gannon, are you in the chat and you're just ignoring us? Is that it? Oh well. Ask your questions in the chat. Folks will see them. Tell me in real time. Well, in somewhat real time.
Got it.
All right. So again, we've got a binomial that's being squared. We're turning it into this side. In the work that I saw yesterday, a lot of people went straight into changing this into sine and cosine. Not a bad move. I would recommend that you do all of the math, like the squaring first, before you do that, just to keep yourself sane. But that's just me, because I'm insane in other ways. All right, so I'm going to start on the left-hand side. Now, again, the one thing that you cannot do, and sometimes you'll see this on YouTube, is that people will play with both sides as they go down. And you can't do that. The reason being is that we're trying to prove that this is equal. We can't assume that it's equal, so you can't, let's say, for example, add 2 to both sides. Not allowed, because we don't know that this actually works.
Mr. Hayes, I have a question though. So like
Yeah.
this year in hat, are we going to give them anything that isn't true? Because I think I had that question earlier.
The pace at which we're moving, I'm going to guess probably not.
Yeah, I think that I would agree with you. I think we're going to stick to things that are always true. So note that when we give you things this year, everything's always going to be true.
However, that doesn't mean that you get to play both sides all at the same time. That doesn't mean that you don't look at both sides, because again, we know we want to get down to here. Okay, so that's where we want to end. So we want to turn this into things with cosine in it. Now, some of you guys maybe in the back of your head, you know that. Cosecant is sine. Okay, well, we can mess around with that. Cotangent is cosine over sine, so we can at least get cosine in that way. So, you know, let's kind of see where things are at. So my first step is, I want to turn this 2 steps, or this, well, what's going to be 3 steps, a quadratic, into something with 1 term as soon as I can. Okay? So for this is going to equal cosecant squared theta minus 2 cosecant theta, cotangent theta. Now going back to that question from the last problem, notice it is perfectly fine to treat this like A and this like B. So we get the first term squared, the last term squared, we get double their product. Charles Vokes and one more. Ooh, Gannon, hi. Gannon. This is the problem when you have guests sometimes.
He said hi. Not sure if you can fix this. There is a little bit of a buzz on your YouTube channel. It's like a little like, I don't know how to describe it.
You don't know how to describe it.
It's like, yeah.
Well, all right, let me try one thing. Hold on a second. Those of you on, well, you don't need to see my big gut. Hold on. Just turn that way. Let me turn this over. I'm going to take out my, let's take off my lavalier mic. And I'm going to just put on the standard computer mic. Transition over. All right, let's see how that goes. Just going to do it the old-fashioned way. Which, given the size of my room, a mic probably isn't super important, but makes me feel important. Isn't that what matters? All right. Let's try that. Hopefully less buzz. It could also be the fluorescent lights that we're working under as well. But
I think I'll check it in a second. It might be okay.
Might be okay. All right, anyway. Gannon mute himself. Oh, all right, let's come back here. Gannon, jump in if you want. Just don't
That's actually perfect. Nope, you fixed it. You're good.
Do the old-fashioned way.
Hey.
You're good.
Ooh.
Which, given the size of my room, the mic probably isn't super important, but makes me feel important. Isn't that what matters?
Wow. Now
you can hear yourself double, right?
Yep, exactly. All
right, here we go.
All right, so anyway, so now at this point, it's going to be the point where you can start changing things into sine and cosine. Why do I need to change things in sine and cosine? Is because we have cosine in the back. And so if we do that, then you need to make sure that, all right, let's see how things go. So we'll go through here. Cosecant is, Gannon, what is it? He's being all quiet.
He's still responding in the YouTube chat. They're actually both, I've got Connor Zenner and Gannon.
Seriously?
Yeah.
Dang. Oh, now I lost my big picture. There he is. Hello, I'm back. All right, so probably threw him the 20-second delay. He thought he was going through a space-time loop. Cosecant is 1 over. Good, sine. So this one over here, I've got the 2 I'm going to keep on the top. Cosecant is 1 over sine. Actually, that'd be sine squared. Nice catch, Mr. Vokes. I think he's too distracted by the YouTube channel. Or he's cooking. All right, so that's going to be 2 cosine theta over, and then, actually, you know what? I'm going to write this out separately. Okay, so the 2 is going to stay on the top. The cosecant is going to come down and technically become 1 over sine theta. This is going to become cosine theta over sine theta. Why am I doing it this way? Because that way, A, you guys can see where things are going a little bit faster, much better than what you photomath or any of those other things that sometimes people use. Plus, and then this is going to turn into cosine squared theta over sine squared theta. So notice now sine times sine is going to be sine squared, so we're going to have a very, very nice common denominator of sine squared all the way across. It's almost, Mr. Vokes, like this was meant to be. So then up here we've got 1 minus 2 cosine theta plus cosine squared theta. And then you may want to rewrite this like this, just because it might be easier to see how to factor it. Still on the screen decently? I got to block that little bit of glare right there. But all right, doesn't matter. Mr. Vogt.
I lagged out for a second, sorry.
That's all right. I don't think I said too much that was bad about you. You can check the video later. So the top is going to then factor into, notice this is that'll be +1 for those of you screaming at home in the background. Thank you. So then this up on the top is going to become cosine theta minus 1 squared. So notice, hey, look. Wait, what did I do wrong? Oh, you could do it either way. Never mind. Ignore where I'm going. This is why I always look at the end, people. I can hear Gannon saying, that's why you never listen to Mr. Hayes. So anyway, so in the top, we're going to factor that out into, so you can set it up either way. We're going to do it this way instead of the cosine first, primarily because that's where we're going. Now the other thing here then is this. Sometimes people, and again, you can skip this step. I'm trying to do one step at a time just for kicks and giggles. What time are we at? Beautiful. Remember this right here, and sometimes just doing work over on the side is extremely helpful. And so this right here, remember, I've got, if I have sine squared plus cosine squared is equal to 1, you can isolate, and I usually try to tell my students when we do this in real time, that you should be looking for either two squared trig functions, or a square and a single, or and the number 1, or if you have anything that's squared, you should immediately be looking at the Pythagorean identities, because all of a sudden, look, if I want sine squared by itself, I can subtract cosine squared, and I'm going to get sine squared is 1 minus cosine squared. So this now turns into 1 minus cosine squared quantity squared. And then in the bottom, I've got 1 minus cosine squared theta, which, as Mr. Vogt said earlier, difference of perfect squares. And so if I factor that, it's like we're supposed to do a lot of factoring in this first group. It's almost like your hat teachers planned it that way. Let me get out of the way. So notice
Maybe
here,
we did.
I know. It's like
too, wasn't it?
It's almost like we talked to each other. So anyway, so we did this. So I changed sine squared into 1 minus cosine squared because I can just rearrange the Pythagorean identity, factored that, and now you should be saying, whoa, 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 I want one of those and I want one of those, get rid of the rest. And so again, I'm going to divide out this and one of these. So that becomes 1 over 1, which then leads into my final answer. In terms of steps, because some of you guys are going to be like, do I need to write all of that down? I would expect to see this. I would probably, if you want to write this as a single fraction, I'd be okay with this.
I mean, you're better off doing more work than less, right?
Yeah, especially if you're going to come back to it. I'm okay if you went from here to here. So if you skip like this top step, if I went from here to here, if you factored the top and then you change this into 1 minus cosine squared, I'd be okay with that. Or if you want to change this to 1 minus cosine squared and then jump into this, that's fine. But yeah, Mr. Vokes' comment that, you know, showing less work usually gets you into more problems is very true. All right. Questions, concerns, panic attacks from the YouTube channel? If Gann is not going to talk, maybe we should kick him out and see if any other volunteers coming in want to say anything live.
I think it's just me and you in the Google Hangout now. So
they're
on the YouTube chat though, so I'm answering questions if they have not. So it doesn't look like they have any.
That's so nice.
Trying.
Did you watch any of that NBA horse competition?
I did.
That was sad.
I turned it off halfway through though because I felt like they weren't doing any trick shots, and then someone told me that they started doing trick shots right after I stopped watching. So.
Yeah, the only one that I saw, Chris Paul was doing some. I think that's only because his kid was there watching. But even then, it wasn't, let's say, like 5th grade horse trick shots. It was just kind of, I need to get an actual eraser, I think.
I have 4 if you need one.
I saw that. You've got 1 million of them up on that board of yours. Do you actually have like 3 people over and you guys all are writing on the dry erase board all at one time, or is it?
No, I don't know. I bought a pack of 4 magnetic ones and I got them on Amazon for like $5, so figured it wasn't a bad idea.
Yay, free shipping from China. They figured out why they can do that. They get so much, they ship so much more than what they get from the United States, so that it's a reciprocal agreement that post offices, as I said, will carry whatever you guys send us. And the Chinese send so much that theoretically it costs us more to ship to deliver their stuff than the vice versa. Anyway, you guys don't care. So moving on. Number 3. This one's interesting because I would say I'm not going to start on the left-hand side, but that's just me.
Yeah, I mean, we talked about this the other day. There's multiple different ways to do these identities, so there's not one way.
And Mr. Vokes, if there's one way that I'm doing it differently than you would, let me know. Some of these I think are pretty straightforward to do.
Yeah, no, I think the last 2 are good.
Okay.
I don't see any issues with those.
I think in group 2 and what we're doing later in the week is going to be a little bit more up in the air.
Yeah.
Oh, look, it's all moist again. Yay. should have some paper towels out here. But as we know, paper towels are about as valuable as toilet paper.
Hard to come by.
See those people online complaining how they can't get the right brand of toilet paper? It's like,
I accidentally bought a ton in January, so I was good, so I didn't have to worry about it.
ooh, somebody saw it coming.
I don't know if it was that.
Should have told the Trump White House about it. All right, so we are going to try to prove that this is equal to this. Again, you can't play both sides. Playing both sides is bad. Not bad like, I don't know. So, play with a more complicated side. A couple of things strike me about this right-hand side. A, it's minus. B, the degree is high, but more importantly, it's quadratic, like. Okay? I've got secant to the fourth, tangent to the fourth. So because of that, what ends up happening is that I can break that down, and you know it's going to be plus and minus, and the square root of secant to the fourth is, hey, look, secant squared and tangent squared. So this one should actually be one of the shorter proofs that you will do. I feel like we should have like a step, like says begin. So people know that we're starting. If that makes you feel better, go for it. I'm going to do it just so that you know where the proof is actually starting. So I've got that. We're going to factor this. So by difference of perfect squares, I'm going to get secant squared theta plus tangent squared theta. Oh, I do want that. That's good. And then I'm going to get secant squared theta minus tangent squared theta. Ooh, I don't want that. So again,
something that's interesting too, because a lot of my students didn't do it this way, and I think that it's one of those things when you get more practice manipulating the Pythagorean identities, you start to kind of see what's going on.
Did they start throwing things into sine and cosine right away?
Yeah, they started on the right side with doing like sines and cosine stuff, and it's not like it's wrong. It's just that it's not as efficient, which is what we want you guys to be.
Correct, and the reason why I wouldn't say that changing this into sine and cosine would make any sense right now. Like on the previous problem, it did because we started with stuff that didn't have cosine and we were ending with cosine. Here, I've got secant and tangent in the beginning on the left-hand side and secant and tangent on the right-hand side. So odds are putting everything into sine and cosine isn't your best move. However, if you get stuck, it's not a bad move to do. So it's a thought.
Yeah.
Now, we've got this mess here. We want to keep this. So the question is, how does this work? Now, hopefully in the back of your head, or you have a separate sheet of paper that you've written down, maybe a piece of cardstock, maybe 4x6 index card, where you're writing down the important ones. When I did my last video, I had all the Pythagorean identities up here in the upper right-hand corner. You've got one that says this. And again, it is perfectly fine. I had a couple of people do some side work and explain it in their flip grid, and I was actually really impressed that they kind of went over and said, okay, this works because, and then they showed something like this. Tangent theta plus 1 is equal to secant squared theta. Okay? Now notice, I've got secant and tangent together. I said earlier, if you see two squared trig functions together, you should be thinking, maybe I can get those to 1. It's not always going to be the case. This one doesn't work. But this one over here, you're like, maybe I need tangent and secant on the same side, so if I subtract tangent squared from both sides, I get 1 on the left-hand side, and secant squared theta minus tangent squared theta here. Hey, check that out. It's the same thing there. So that's actually going to equal 1. Mr. Vokes, would you want them just to say something like, would you want the 1 down actually here in the line, or would you be okay if you did something like this and you said that equals 1?
I'm honestly okay with it if you have the side proof that you show that, because I think that it shows, as long as you have that side proof, that you're good to go.
Yeah, I'm kind of the same way. And I said this in one of my earlier videos that sometimes the nice thing about factoring with trig functions is that you know I want one of these. So you kind of know that this is going to be part of whatever this is going to factor out to. So because you kind of know where the end is going, you're just proving that it works. Can I get from place A to place B? So you can kind of have a sense of what you're looking for.
And also because we told them that everything we're going to prove is true, I think that they should also remember that if you have what you want times some complicated expression, that expression should be 1 if you're doing multiplication here.
Right. And you may have to do it. It may not be a one-step thing like this, but yeah, you should be able to play around with it and do it. I've had some professors, when they do this, they actually kind of just break this part off over here and mess with it, and then they bring it back in, and that's fine too. So that way you're not having to rewrite this over and over and over again.
Yep.
But just so long as you're showing some sort of equality that this equals this, that equals this, that equals whatever you're ending up with. It's a lot like, what do you call it? Transitive? Yeah, it's not substitution, it'd be transitive property from geometry. Haha, see, you didn't think it was going to come back, did you? All right, let's get moving. So, let's jump into the fun ones. Now, by the way, if you were thinking about it, all 3 of those did have to involve factoring, and that's part of the reason, and we did that on purpose, okay? The whole idea there was to kind of make sure that you had a factoring problem to do, because you will have to use those factoring skills from first semester. Basically for the rest of your life if you do anything in sort of math classes. Can't promise.
So we have a question too. It says, so the majority of solving, is it just like putting the identities and substituting the identities that you know into things that you see?
That sounds like a pretty good definition of doing trig identities to me.
Yeah, I agree.
And that, to be honest, is one of those weird things sometimes where you're like, I've had students oftentimes be able to do trig identities just fine, but they don't feel comfortable with, they're like, I can do it, I can get it right, I have no idea what I'm doing, because they just kind of get into that feeling of, all right, I'm going to manipulate this. But more often than not, by the time we get done with it, if they've been doing the work and doing all the problems, they'll kind of have that one day where everything will kind of click, and they're like, oh my gosh, that's all we're doing. I'll be right back. I'm going to get a dry rag. Mr. Vokes is going to regale you with something.
So yeah, I mean, a lot of this boils down to is that you guys are just using the identities that we know and, you know, substituting them in, but also don't forget, like Mr. Hayes said, our first set from yesterday was factoring. So factoring is important. Make sure you know how to factor. That's one thing. Fractions is huge in this also, so keep that in mind as well, as the idea of fractions is going to come up a lot in what we do.
And that's going to mean that you're going to use either the reciprocal identities, so you're going to change like sine into 1 over cosecant, or you're going to change things into the quotient identities, so sine is, or tangent's going to be sine over cosine, things like that. And that would be stuff I'd put on your index card.
Yeah, and
Seriously.
the thing is, as you find more identities, the more that you have on that index card, the better you get with them, but also like then you have all those little side proofs that on your index card, and you're like, oh, all I have to do is copy down that little side proof, and it makes my main proof a lot easier to look at, but also a lot more believable, if that makes sense.
Yep. This one I had a couple of questions on yesterday.
Yeah, this one I have another way to think about it. So this one's good. I like this one.
And the way that the first couple of hints that I gave, because again, I'm like, you know, walking around, I think of one of the times I was doing laundry and I'm like, oh yeah, just na. It was, I think I suggested that you should be able to turn these into some sort of, I should be able to, well, first of all, I said change those into some sort of Pythagorean identity, one of which didn't work. I suggested then also substituting out either the 1 or the tangents, and something should divide out, and it actually really didn't work out so well. So, let me show you a couple of options. So we're going to start with the first step. So Mr. Vokes, if this isn't, well, how would you go about it? Let's start there.
Well, there's a couple of ways that I thought about this.
Okay.
And the first way was to change the 1 on the bottom into its Pythagorean equivalent. So
like for the tangent, we have tangent squared plus 1 is equal to secant. So you would say, okay, make this one here into secant squared minus tangent.
Yeah.
Then wouldn't we come up with two tangents then? Is that going to be a problem?
Oh wait, did I do it the other way? Maybe I did it the other way. Did I change the tangents squared? Oh yeah, I think I changed the tangent squared. Oops.
Okay. That.
Yeah, I think I changed the tangent squared into secant squared minus 1.
Okay.
Yep.
That's right.
And that's the thing. Like I was live yesterday too, and I even made a mistake. And it's like, yeah, like if you make a mistake, that's fine. Just come back to it and think about it in a different way. So like, I remember I did something with the denominator, but I couldn't remember exactly what it was. And then, oops, that doesn't make sense. So as you're like talking about it with people, start to think about, well, does that move make sense? Does that help me get to the end goal?
And that's where, again, just trying it is going to be important. So anyway, so if I do this, this is really secant squared theta minus 1. Now be careful, make sure you guys put this in parentheses because this negative is going to go to both of these. So then this is going to turn into, this fraction is 2 minus secant squared, right?
Yeah.
All right. I'm assuming you did something similar on this side?
Yeah, I think so.
Okay, so...
Is that what I did? Now I can't remember if that's what I did. I don't know, is it going to help us?
Cotangent is going to equal secant squared minus 1. Well, to get... Wait, that shouldn't be secant. I wrote it down wrong. Let's go secant.
Cosecant.
So that would be an example of, so then this over here, we got 1 minus cosecant squared theta minus 1. So that's going to be 2 minus cosecant squared theta. We're trying to get to 1, so if we could find a common denominator between these two, hopefully things would divide out.
Yeah, that would work.
And that would be one of the things that you could do. I mean, and some other thoughts that people had asked, some people had said, well, this is difference of perfect squares. Could I factor that into 1 plus cosine, 1 plus, or 1 plus tangent, 1 minus tangent, except same thing over here. It doesn't really get you anywhere. This over here, if I multiply this, and to be honest, if I'm going to multiply this by 2 minus cosine squared theta over 2 blah, 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 and the same thing on this side, you might as well have done it up here.
Yeah.
So you could have also just said, okay, I'm going to bite the bullet. We're just going to use the hammer, beat our way through this, and say, okay. Now the benefit of doing it this way, so that's going to be up over here. Is what is tangent, and you kind of get it down here too, what is tangent times cotangent going to turn into?
1, because they're reciprocals.
Hey, look at you. It's like you have a math degree or something.
Something like that.
And I'll show you a way you can probably get around it too, but we'll get there in a second. So if we did that, oh, I gotta erase that other thing too. This is the point, Mr. Vokes, where usually somebody raises their hand and asks if they can drop the class.
Yeah.
All right, so 1 minus... What are you doing?
Me?
Yeah.
Nothing. I'm just moving around in my study. It's very creaky in here. My floors are very loud.
All right. So, a couple of things for those of you guys who are panicking right now. First of all, no, you cannot just go 1 divides out 1 and those divide out and those divide out and those divide out. No. Factors, not factors. Technically factors and add-ins. Not the same thing. But you will be pleasantly pleased. I hope. So the top, if I simplify this just a touch, I'm going to get 2 minus cotangent squared theta minus tangent squared theta. On the bottom, if I multiply this out, 1 times 1 is 1. I will get a minus cotangent squared theta. Hey, that looks good so far. I will get a minus tangent squared theta. And then I will get a plus cotangent squared theta tangent squared theta, which, as Mr. Vogt so eloquently said earlier, is equal to 1.
Yes.
Uno. Eins. Uno. So this is going to equal 1, which means that I really have on the top 2 minus cotangent squared theta minus tangent squared theta, 2 minus cotangent squared theta. Oh my gosh, it's the identical thing. And when you take something and divide it by itself, it's the same thing. Exciting, I can tell. So exciting that we've had people leave. Oh well. Now, so that'd be one way to do it. A different way, I'm going to get rid of some of this up here, so if you're still copying.
Yeah, the other way to do it is just to basically just change everything to sines and cosines. And
oh, you can do that. I have a simpler. Here, check this out. You ready? You ready to be amazed? If I take this, yeah, you can do sine and cosine, and everything works out very nicely there. I'll tell you what Photomath did. They did this first. So now I have everything in terms of tangent. And then they multiplied this by tangent squared over tangent squared. So then this is going to stay like this. This, by the time I multiply this out, is now going to become tangent squared theta and then tangent squared minus 1. And you might be saying, but Mr. Hayes, that's the opposite. Remember, if you've got the terms, but they're just opposite signs, you can factor out a -1. This is going to equal -1 times 1 minus tangent squared. That can go up in the top. So my new denominator is going to be 1 minus tangent squared theta. On the top, this is going to stay 1. This minus is going to go up top because, again, it's -1. You can put it wherever you want. Minus tangent squared theta, and that's going to equal 1.
Yeah, and that same thing happens when you do the sine and cosine version of it too, where you have to take out a negative. So that's something to keep in mind, is that that's maybe a new, I don't want to call it a trick, but it kind of is. It's like a thing in your tool chest to help you. And taking out a negative from something can help, because then you can make things work in the way that you need to.
Factoring out a -1 can really kind of change it. So if you're like so close that it almost works. Man, I had this joke that I thought it just totally left. It was going to be perfect. It was an analogy, actually. So, those of you guys playing along at home, I'm going to start erasing. Feel free to come back and hit pause so you can check this. We still have 2 more of these to do. I hope people are not disappointed. I should go through.
Sorry, I cut out there for a second if I wasn't talking.
No, it's okay. I was just commenting aloud that I should go through and double check the time indexes on this so I can put that down in the description. So if people want to jump to a particular problem, they can just jump on it and just say, oh, at 35 minutes, 16 seconds, he started this problem.
Yeah, I should have done that for mine yesterday too. But we're learning, so that's helpful.
Oh, it's just nice to have somebody else here. Thank you, Mr. Vokes.
Yeah, no problem.
I would say you're my favorite hat teacher, but you know.
You don't want to say that. because if that's
People would
now
be
the other
jealous.
2 teachers are going to watch the video and they're not going to feel good about themselves, so we don't want to do that.
Nope. You're the hat teacher I've known the longest.
That is true. I think it is also nice though, because I don't know, I'm quarantining by myself, so it's one of those things where when I get to interact with other people, it's just nice, you know?
Have you started talking to yourself yet?
No, I have not. That's
Okay.
a good sign, right?
Yes.
Okay.
Before I got married, I was living with my parents for a while because we were in the process of getting ready to get married, and they went on vacation for 2 weeks. And I found that if I didn't start talking to the dog in the morning, I had a hard time in my first hour class because I hadn't spoken yet to anybody. So I started talking to the dog. Life
This
pro
one I
tips.
think is one where I saw a lot of mistakes. And I think the reason is because we had a hard understanding of like when we can make multiple fractions.
Yep. And this is going to be one of those ones, and you can work this in either direction. Okay, and normally, Mr. Vokes and I would say start with the more complicated side. Generally, fractions are more complicated. Okay. The one thing which you do have to think about, however, is can I turn this into 2 pieces? Or is there some way I could turn this into something with a secant in the bottom? Now, if you notice, I've got cotangent here. It'll probably run through both directions, I think, to be safe. Let's start with the way that probably more people did it, and then we'll kind of go from there. Does that sound like a good plan?
Yeah, and I think most people would start with the left, right?
Okay. So if I've got this, but this is a step which unfortunately a lot of people, they're very good at getting common denominators. They're not used to separating common denominators. I've got 1 plus cosecant theta over secant theta. What is the 1 being divided by? Secant theta. What is the cosecant theta being divided by? Secant theta. So you can break this into 2 separate fractions. Why would I want to do that? Because I got 2 separate terms up here. Okay? Now, the other thing that sometimes I will suggest if people get stuck, a lot of times people can see that this is equal to cosine. Other times people will sometimes write this as 1 over cosine, which I think is a perfectly fine way to do it. I know a number of you guys did that yesterday, and then you just said, oh, well, then I'm going to multiply it through and get this. So technically that's over 1. Either is fine. One thing that I find useful if I've got these together like this is I will sometimes break this up into cosecant theta times 1 over secant theta, because then it's going to be easier to see how these things will flip around. Cosecant on the top turns into 1 over sine theta. This is going to move up to the top and become cosine on the top, much like what we have over here. So then this is going to turn into cosine theta over sine theta. Now again, remember, we're trying to get cosine theta plus cotangent theta. So we already now have, we've gotten half the problem done. We have this, we wanted it, we're not going to touch this. Some of you might be saying, is there a time where we might? Yeah, there might. It's not going to be in this course. I don't think it would be in honors pre-calc. So then obviously this, I've got cosine over sine. Again, we know we want cotangent. So just by definition of tangent or one of the reciprocal identities or one of the quotient identities, oops. Get that. Bingo. If you were running this backwards, this is how it would look. Let's say if I started here. This would be one that I would definitely say writing in terms of sine and cosine would be good because I have a cosine. This I need to get cosines to. So I would get cosine theta over 1 plus cosine over sine. And And then at that point, you could get a common denominator. I can multiply this by sine over sine. So I get sine theta cosine theta plus cosine theta over, so now I've got my new common denominator of sine theta. And then you can start pulling stuff out. Hello.
Yeah, and then we factor out that cosine. That'll help us.
Pardon me. Yes.
Yeah.
I'll be back in 10 seconds.
Yep.
See, that's quality television right there, people.
Right?
Motion sensor, the light goes off. I'd help get my son up off the floor. 110 pounds of dead weight. So now we're going to try to break it into that. So again, what you can end up doing here, check this out. I can factor out a cosine, which is going to turn into my secant. And if you ever take math in college, this would be the exact point where your professor will say, and the rest of this I'll leave to the proof because it's easy enough for you guys to figure it out. Which generally is him or her saying, I don't want to bother. So once you do that, then you can start moving this stuff up around. The cosine can come down and become secant. The sine can go up and become, these two will switch. This seemed a lot nicer in my head when I thought about it.
Yeah, it's a little, I mean, it just gets a little tough because some of these ideas, like you talking about flipping the cosine and the sine, those are things that, like, as you start to think about doing these more, you start to see that more. Like, I actually just did the one we just did, the last one, number 4, whatever it was. I just did it in a totally different way, but because I thought of something after we're talking. So it's like, you can do these in so many different ways.
Yeah, so when you multiply this out, you get cosecant sine, which is 1. Cosecant times 1 would give you the cosecant, and you get that. So it, and again, different people are going to do different ways. One of the things that I always found hard about grading these is the fact that for a particular identity, you might have, especially some of the more advanced ones, I mean, the more difficult ones, what would you say, Mr. Brooks, 3 or 4 different answers that people could legitimately come up with?
There's a great question actually right now.
Yeah.
So the one question that's on here talks about, can we change the cotangent squared? And I think it's getting to the idea of, like, if we have like 1 plus cotangent, is it the same as like being able to replace it with cosecant? And the answer is no, because you don't have the squares. So the Pythagorean identities can only be used when you have things that are squared.
And whoever asked that is a very common issue for people, especially in the beginning. They just, you see sine plus cosine, and you immediately say, hey, that should be a 1. And, well, not really. I'm glad that you're thinking that way. And it's a very common thing to have happen. So if you're doing that, that just means that you're probably taking some good steps in terms of having your brain start to think about what should go on. So, oops. Is that good enough?
Yep.
I think so. Now get all the little extra moisture off. This is the benefit of not doing live, is because I can cut this out of my other videos. But then we wouldn't have quite the witty banter that we're having that you guys pay us for, would we? Last problem, number 3. How many of these do you think we're going to see now get done, Mr. Oakes?
I mean, I think it's all about just like exposing yourself to more examples. And we're going to post videos as we go throughout the next couple of days too, as we go through things. I mean, I think that's the important part is like watching us talk through these. And now I think there's 2 sets of videos of us talking through these like this. So I think that's just important to keep doing. The more you get to like look at these and kind of get them, the quicker they go for you.
And that's part of the reasons why I wanted to kind of do this together with you, Mr. Brooks, just because it's one of those things where sometimes the way that I explain, it's sometimes easier to bounce ideas off of each other.
Yeah.
Than it is
and to point out, we got stuck at one point where we're like, no, that doesn't make sense, and we went back and we fixed it. So it's like one of those things where like that happens even with us. So I mean, just being okay with that and being like, nope, that doesn't seem to make sense, and asking for, hey, what was the most efficient way? That's also something you want to be thinking about.
And I know it's shocking that the 2 of us would get stuck, but you know, he said sarcastic.
That's what happens on live TV.
Hey. All right. So, have you gotten to the point where you want to cut your own hair yet, Mr. Brooks?
No, I have not. I'm going to see how it goes.
Okay,
I'm
close.
see how this goes.
All right, anyway, so more complicated side is definitely the left-hand side. We want to end over here with secant. So, if I'm going to start here, and some people were just going straight from here down into it. I think I actually may have done that on my last video. You really should rewrite it fresh. Because, you know, Mr. Vokes and I don't raise no lazy mathematicians. Oh, I forgot the plus tangent. Speaking of lazy. So, thoughts off the top of my head, Mr. V, is this is half of the factors of a difference of perfect squares.
Correct.
If this was 1 minus sine squared theta, I could turn that into cosine. And that would get me from 2 into 1. So that would be a very, very helpful thing. Tangent is sine over cosine, so that would at least get me closer to having a common denominator. And if you're at home saying, why, how in the world would I be expected to know that? Yeah. Out of the 3, we try to, each of the different hat teachers put together these things, and we try to have at least one that was a little bit of a stretch. So I'm feeling that that's probably our best bet. What about you?
So what I did, and this is something that seems kind of nasty, but it works, is if you change tangent right away to sine over cosine,
okay,
and then just multiply by the other denominators.
Just go straight into common denominators?
Yeah, just go right into common denominators. It doesn't seem like it would be very nice.
Sure.
But honestly, think about it. Again, we told you guys everything should be true.
And I think
that's key.
And I think to your point, I think that's more natural. I mean, the thing that again, like, and you've said this better than I have over the course of this streaming session, was the fact that, you know, understanding that this can go into 1 minus sine squared, and I can multiply it down to make it all look nice and elegant. That's something, I mean, I've had, 6 or 7 eons of experience doing this stuff. Where something like this, you just, to your point, you know it's going to get cleaned up. So sometimes, even if you kind of just do it by brute force of saying, okay, well, I'm going to do this, so that means I'm going to multiply this by cosine over sine, or cosine over cosine. Make sure you put that there. And I'm going to multiply this by 1 plus sine theta over 1 plus sine theta. This is going to be nasty. I'm going to trust it's going to turn out to be nice.
Yeah, and the thing is that you have 2 terms on the left, and if you get them all to be 1 term, which means get them together as 1 fraction, it should work out in the end.
Yeah. Now, okay, here's another good question for you, Mr. Vokes. Should I multiply this out now, or should I wait?
I think you should wait.
Okay. That's the thing that I've been saying to most people who do stuff is, and I understand, it is very natural, given where you guys have been with math, that, hey, let's multiply all this out. However, since we're talking about probably having to divide some stuff out to get over here to my secant squared, I would wait until there's a real need to. Particularly since cosine times sine isn't going to get you anything. If this was cosecant, in sine where it turns into a 1, it might be worth it. But for now, you can always do it later.
Yeah, and I think it just comes along with what you just said about it, us needing something to probably divide through to be 1 so that we can, get the secant that we need.
Now up on the top, a couple of things. Check this out. I've got cosine and I've got sine. If I multiply this out, I could get a sine squared up there. That might be helpful.
I would think so, yeah.
Okay, so let's do that. So this would be a case, but again, this is something, could I have done it up here? Yeah. But again, as Mr. Oak said, I would hesitate to do it just because you may cost yourself some time later. You can always, it's always better to take an extra step than having to take 3 extra steps because you're trying to save yourself time. At this point of your trig identity careers, trying to take shortcuts is not going to be your best friend. All right. I'm going to switch these 2 positions here. I'm going to put the sine squared here and the sine here. Why? Because this equals 1. You should be having a little bell going off in the back of your head. So that turns into a 1 plus sine theta over cosine times 1 plus sine theta.
Now, the thing that's hard to see for some of our kids, I think, is that the top could technically be perceived as 1 factor. I think that's the hard part for some of our kids right now.
Meaning, oh, like the whole thing that cosine squared plus sine squared could be one whole thing to take out?
Yeah.
Yeah. And that's where, again, having that sheet, I mean, here, I'll show you. And this is just so I can not have to hem and haw through it. Over here, I've got this. I don't have everything written down, but I've got my Pythagorean identities, and I've got sum and difference, which is something that we're probably going to do in a couple of weeks, okay? But I've got them all out here just so I can refer back to it so that I don't have to try to think through it. If I use that enough, I'm going to just be able to do it, and I have it here just because I want to be clear to you guys. Also want to seem like I'm awesome.
That too.
But Mr. Hayes is awesome in math. That's being a nerd. Yeah, well, whatever. But yeah, so no, that's a really good point. Like you feel like, and so at this point, again, remember the one thing in the back of your head, look for 1, if you have a 1 in a squared term, that should be a tip-off to look at your Pythagorean identities. If I have 2 squared terms, that should be a tip-off that maybe that's going to equal 1. So when you get that, I get this. And here's a step that a lot of you guys trying to go through fast miss. A lot of you guys would be like, hey, okay, those are going to divide out, so now I just get cosine theta. No, when you divide these out, what do you get? Remember, this is parentheses right here. This turns into a 1, and this turns into a 1. So this is really, is it still on the screen? Yeah, barely, okay. 1 over cosine theta. And then that
that's the hard part for them to see. I think that's the hardest thing.
Yeah. And that's, and again, I understand why it is. You're like dividing stuff out, et cetera, et cetera. And I think part of that's just because, unfortunately, in math education these days, the going through and hitting some very good basics of when you divide this out and replace them with 1s, like Mr. Vokes said way back. How's this for bringing it all the way back to the beginning, Mr. Vokes? I'm saying that replacing these with 1s really doesn't happen that much, so you guys aren't used to that. So when you do that, then I get 1 over cosine and get down here, and then I get my little QED.
Yeah, and the thing about it is, as you said earlier about the cancel out idea, is like in math there's so many cancel outs that we have to be careful with that, because then that's where you don't necessarily see this understanding come through. So,
anywho, so those are the problems that you had due for today. Well, last night, due today. Probably far longer than you ever wanted to sit here and listen to Mr. Hayes and Mr. Vokes yammer on. How far did we get? Hour 14. Holy crap, that's 15 more minutes than I wanted. Anyway, but again, could we have done it faster? Yeah, part of it is that we wanted to make sure that we explained why we were doing what we were doing. So anyway, Hopefully that helps. If not, shoot us an email or, put some comments down here. Hit subscribe and like. Make sure you hit the little bell. Anything else I'm missing, Mr. V?
No, I think we're good.
Okay. Well, I think this worked out well.
Yeah.
Maybe we'll have another guest star some other time. I'm still mad Gannon didn't jump in.
He was talking, and he actually just thanked us, so
good.
We're good.
Sorry! He always feels like I pick on him, and sometimes I do. I tried to get away from that. I'm sorry. But now you have evidence, and this is why I can never run for president, because there's going to be all this stuff on the internet. All right. Anyway, hang in there. Biggest thing is let us know what's going on. So, anything else for the good of the order? Any good final parting words, Mr. B?
I think we're good.
All right. I'm going to end this here. Talk to you later.